Good morning, Cappuccino. It's actually nighttime here in my house, but I wanted to get a head start on putting my videos together for tomorrow. Well, for you, it's today, April 29th, because I seem to have been a big sleepyhead in the morning these days, so I function better at night. So here we go. Here is our warm-up for April 29th. I advise that you use a calculator. I do not think you want to do this without a calculator, especially Part B. Part A, you could probably handle. It would be tricky, but you could do it. But Part B, this is hard, okay? So here's how the extra credit's going to work. 5 points extra credit for the first 5 people who can just answer Part A. The first person who can figure out Part B will get an additional 10 points extra credit. I'm trying to see just how high we can get those grades to go. What the heck? Why not? Okay, so we have this region R. That's the green region here. It's bounded by y equals 0, x equals 5, and y equals x squared minus x minus 6. Diagram is not drawn to scale. Okay. Find the volume of revolution around the x-axis. Okay, so we're going to take this green thing and we're going to rotate it around the x-axis. That's Part A. Not too bad at all. Okay, but do use your calculator, right? Don't make your life a living hell. Okay, Part B. This is going to make your life a living hell. Find the volume of revolution around the y-axis. Good luck. I actually figured out 2 different ways of doing it, so I'm sure you can figure it out. Okay, you know everything you need to know to solve this problem. Okay, so I was a big sleepyhead this morning, and when I gave you, or on the 28th, so when I gave you the warm-up, I forgot to go over the previous warm-up. So let's go back, bam, right here. So far, everybody who's turned this in did not have a hard time with problem 1. They realized, I mean, there's a bunch of ways you could do it. The way that I do it is I just say, well, what's my rate of change here? I'm adding 3, I'm adding 3, I'm adding 3. Okay, we have a constant rate of change. So this would be a line. If I were to graph this, this would be a line, and my slope or my gradient would be 3. So already I know I have y equals 3x plus b. Okay, to get the y-intercept, that would be when x is 0. So I could just say, oh, well, let's go backwards. What would 0 be? Okay, so if I go this way, I'm going to minus 3. So 2 minus 3 would give me -1, because -1 plus 3 is positive 2. So I know my y-intercept is -1. So that's the easy peasy lemon squeezy way of getting it. You could also have used your slope formula, m equals y minus y over x minus x, change in y over change in x, and then you could have used y equals mx plus b and plugged in your slope, plug in a point from the table, and solve for b. Okay, lots of ways of getting the answer here. You also could have graphed it and just looked at it. All right, the next one was a little trickier. But I have gone over this before. What do you do when your logarithms have different bases? Well, we want them to get to the same base. So what could I change these both to? I could change both of these to a base 2. So I can rewrite log base 16 as log base 2 to the 2 times 2 is 4, times 2 is 8, times 2 is 16 to the 4th. Okay, and then this one, log base 2. Okay, 16 times 2 is 32, so this would be to the 5th. 0.3. Okay, and then we could do the change of base rule. If I change these to blah, blah, blah. Well, anyway, I did this before. We can do this change of base thing. I don't really want to do the whole thing on here to prove it again, but we figured out there's a little shortcut. If you have an exponent here, you can just change that to the reciprocal in front. So this is equal to 1/4 log base 2 of x minus, and since this is a 5, it would be 1/5 times log base 2 of x is equal to 0.3. Okay, now you can see that I have these in common. So I can factor that out. So I'm going to have log base 2 of x times 1/4 minus 1/5 is equal to 0.3. 1/4 minus 1/5, we had a common denominator, that would be 20. So this would be 5/20 minus 4/20 times log base 2 of x. So that would be 1/20. This is 1/20, so I have 1/20 log base 2 of x is equal to 0.3. So I want to get rid of that times by 1/20, so multiply by the reciprocal. So I'm going to multiply by 20 on both sides. And I'm left with log base 2 of x is equal to 6. And then change it to exponential form to get x by itself, and I get x is equal to 2 to the power of 6. 2 times 2 times 2 times 2 times 2 times 2 is 64. So that was the answer to that one. Okay, now this one, we want to find the volume when rotated around the x-axis, so I need to know the equation of this. So this is related to the previous problem in that I want to write the equation of this line. So again, I want to do y equals mx plus b. So my slope, well, it's negative. It's going downhill. How far down is it going? Because it's change in y over change in x. Change in y is 4, change in x is 3. So it's negative 4/3 x, and there's my y-intercept plus 4. Okay, so there's my function. So to find the volume, my volume is going to be equal to pi. And the integral, I'm going to be evaluating this from 0 to 3. I can see that that's where the x-intercept is. And it is going to be negative 4/3 x plus 4. And don't forget to square it because we're doing volume. And then I'm going to grab my handy-dandy calculator. I could do this by hand, but why should I? That would just slow me down. So I'm going to put this into my calculator. So I'm going to have negative 4/3 x plus 4. The whole thing's squared. There it is. I'm going to graph it. Blah, blah, blah. There it is. Second calc. Oops, I did something wrong. Second calc. There we go. Option 7. Lower limit is 0. Upper limit is 3. And it gives me my answer, which is 16. But don't forget the pi. So 16 pi units cubed. There's my volume. Okay, so now I want to do it around the y-axis. So I need to take this equation and solve it for x, because I need to, because that's what I need to do. All right, so I've got y equals negative 4/3 x plus 4. So I'm going to minus 4 from both sides. Y minus 4 is equal to negative 4/3 x. To get rid of that times by negative 4/3, I'm going to multiply by the reciprocal. So multiply by negative 3/4. Got to do it to both sides. Times negative 3/4. So I get negative 3/4 y. Negative times negative is going to give me a positive. The 4's are going to reduce out. So I'm left with plus 3 is equal to x. So there we go. There is my equation that I now need to rotate around the y-axis. So my volume is going to be equal to pi. And I'm going from 0 up to 4 this time. Notice where I'm crossing that y-axis. I'm going from 0 to 4. Okay? And I have my equation, negative 3/4 y plus 3, the quantity squared dy. All right, now I can use my calculator again, just like I did on this one. So I'm going to go back to my y equals. We'll clear that out. I'm going to have negative 3/4. I have to use x because there is no y. Plus 3 squared. Graph it. And then evaluate it. All right. There we go. Option 7, I'm going from 0, upper limit 4. And I get 12. Isn't that spectacular? So volume is equal to 12, and don't forget the pi. Units cubed. All right, so that takes care of the last couple days of warm-up. So the 27th and the 28th. Okay, now that I just went over this, think about what I just did here and apply it to this. This is quite a bit harder. Not the first one. The first one's not bad at all. But this, it's tricky. So good luck. Again, you don't even have to attempt this if you don't want to. You can just do this one if you want. But for those of you who are planning on going to HL next year, or you're going to be a STEM major, give this a try, okay? First person who gets it gets 10 points extra credit. And the first 5 people who get this one get 5 points extra credit. And for that lucky person who gets them both right, yes, you guessed it, you can get 15 points extra credit. Okay, on your mark, get set, math!